Hey guys, welcome back. So in the last video, we saw how to insert a new node in a double linked list. Hope the concept was clear. Now in this video, let's see how does the algorithm for insertion looks like. So the name of the method is insert in a linked list. It takes head reference, the value that needs to be inserted in that node, and the location where the node needs to be inserted. So first of all, we create a blank node and insert a value in it. Once that is done, we check that if linked list does not exist, in that case we simply return an error saying that the linked list does not exist and hence we cannot insert a new node. In case the linked list exists, so we go to this else if block. Here we check a condition that if location equals 0. That means if we want to insert the new node at the first position. In that case, what we do is we update some of the reference variables. So let's say the new node that we want to insert at the first of a linked list is node 5. Now this is located at address 555 and having value 50. Now all that we need to do is we have to update node.next is equal to head. Now what is node.next? We are talking about this reference here. So we have to update it and put a value 001 here. Now as soon as we put 001 here, automatically a link gets created between node 5 and node 1. Now the next step is node.previous is equal to null. What is node.previous? We are talking about this reference here. So we insert a null over here. Now why we have inserted a null? Because this is the first node and there are no more nodes before this. So there is nothing that it needs to point to. Now once that is done, the next step is head.previous is equal to node. So what is head.previous? We are talking of the reference variable here. So right now it is null. So we insert 555 here. So as soon as we insert 555 here, a link gets generated between node 1 and node 5. Now the last step is we have to update head. So head is equal to node. So head was previously pointing to node 1 which we want to delete and we want a connection between head and node 5. So to do that, all that we have to do is we have to update the address of node 5 which is 555. So with that we have successfully inserted a new node at the start of a linked list. So all that we have done is we have to create a blank node, insert the desired value in it which is 50 in this case, then update the next reference of node 5 to point to node 1, update node 1's previous so that it can point to node 5 and finally update head so that it points to node 5. Now let's say if we want to insert a new node at the end of the list. So how do we do that? So for that we have this else if block over here which has few reference variables to be updated. So the steps are again same, that is we first create a blank node. Let's say node 6 is the node that we want to insert at the end of this list. We update a value here. Let's say we want to put value 60 here. Now the next step is node.next is equal to null. Now what is node.next? We are talking about this reference here. So we put a null over here. Now why we have put a null? Because there are no more nodes after this. The next statement is node.previous is equal to tell. So what is node.previous? Node.previous is this reference here. So it needs to be equal to tell. So the value of tell is 333 right now. So we put 333 here. So as soon as we put 333, a link gets generated between node 6 and node 4. Now the next step is tell.next is equal to node. Now what is tell.next? We are talking about this reference here. So we update it and change the value to 666, which is the address of node 6. As soon as we do that, a link gets generated between node 4 and node 6. Now the last statement is tel is equal to node. So tel, as we already know, should always be pointing to last node. Right now it is pointing to node 4, which is not the last. So we have to update it and change the value to 666. So this will destroy this link over here and it will create a new link between tel and node 6. So with that, we have successfully inserted a new node at the end of a list. So what we have done is, we have created a blank node, inserted a value in it, updated the next reference of the new node to null because it is the last node. Previous reference of the node needs to be updated to be equal to tel because we need a back connection between node 6 and node 4. Then we updated the next reference of node 4 to point to node 6. And finally we updated tel over here because tel should always be pointing to last node. So we have seen how to insert a new node at the end of a list. Now let's say if we want to insert a new node anywhere apart from first and last. So in that case, the control goes to this else block. Let's see how does this works. So let's say node 7 is the new node that we want to insert in between node 2 and 3. So how do we do that? The first step obviously is to create this blank node. Let's say this is node 7 and the address of this node is 777. Next we have to insert some value in it. Let's say we insert 70. Now we have to create a link between node 7 and node 3. Also we need to create a link between node 7 and node 2. Now to get to the address of node 2, we have to create a loop. And the loop should be starting from first node and keep traversing towards right till we reach node 2. So for that we have a loop here which starts from 0, goes till location -1. Why -1? Because we need to stop at the node which is exactly before where we need to insert our new node. So in this case we want to insert our new node in between node 2 and node 3. So we have to stop our loop at node 2. Now at the end of this loop there is a reference variable called temp node which is having the address of node 2. So right now as we see that there is a reference called temp node and it is having value 111 which is address of node 2. Now what we do next is node.next is equal to temp node.next. Now what is node.next? We are talking about this reference here. Here we have to insert temp node.next. So what is temp node.next? Temp node is 111. Temp node.next is 222. So we insert this 222 in node.next. So we put 222 here. As soon as we put 222 here, a link gets created between node 7 and node 3. Now the next step is node.previous is equal to temp node. So node.previous is this reference. We have to insert temp node. What is temp node? Temp node is 111. So we insert 111 here. As soon as we insert 111, a link gets generated between node 7 and node 2. So till now we have successfully created a link between node 7 and node 3, also node 7 and node 2. Now all that we have to do is we have to create a link between node 2, node 7 and node 3 to node 7. So for that the step is temp node.next is equal to node. Now what is temp node.next? Temp node is 11. Temp node is 111. Temp node.next is this value here. So right now it is having a value 222. We need to update it and put a value 777 here. Now 777 is the address of node 7. So automatically a link gets generated between node 2 and node 7. Now we are left with only one last step, which is we have to link node 3 and node 7. So for that, node.next.previous is equal to node. So what is node.next? Node is 777, dot next is 222, dot previous is 111. So over here we come and we update this value, change it to node, which is 777. So automatically this will create a link between node 3 and node 7. So with that, we have successfully inserted a new node in between node 2 and node 3. So if you want to quickly recap what we have done, we have created a blank node, then we have looped starting from first node till the node where we want to insert our new node. Once we have that in place, then we inserted a value in the new node and updated the next and previous reference of the new node. After that, we have updated the next reference of node 2 and previous reference of node 3. So doing all this will successfully insert a new node in between two nodes. So now I hope that we have understood how to insert a new node in double linked list. Now let's see what is the time and space complexity of this operation. So first of all, we are creating a blank node and inserting a desired value in it, which will take a constant time. Then we are checking if the list is existing or not. If not, then we are returning with an error message. So this will again take constant time. Next, what we have done is we are going to an else if block for if we want to insert a new node at start of the list. In that case, we are updating few reference variables, nothing more than that. So all of this will take order of 1 time. Similarly, when we want to insert a new node at the end of a list, we have to update some of the reference variables. So all of them will take order of 1 time. Now if we want to insert a node in between any of the nodes, in that case we have to create a loop from start and go till the location where we want to insert a new node. So in the worst case, we might have to travel almost the entire list. So this will take order of n time. Once that is done, we are updating some of the reference variables which are constant time operation. So if we add all of these statements over here, we get order of n time complexity. Now for the space complexity, it will be order of 1, and the reason is we are using some of the temporary variables here and there, nothing more than that. Since these temporary variables are not in proportional to the size of the list, the space complexity will be order of 1. So with that we come to end of this video. I hope you have understood how to insert a node in the double linked list. In the next video, let's talk about how to traverse a given double linked list. Thanks for your time. See you in the next video.